Okay, well, welcome back. This is the next in the series of the Carbonyls pack, and you need your notes, and we're on page 19. So we're looking at the iodoform reaction. Now, the iodoform reaction is a test for various compounds, but unlike all the other organic tests, it doesn't test for a single functional group or group of atoms. It tests for 4 different functional groups. So we're going to look at that in detail. So you'll need your pack and you'll need a pen, and we will start. So there's a little video that goes along with this, but also you can find lots of different videos about the iodoform test on the internet. So there are 4 molecules we need to look at. The first of all one is ethanol. So this is our primary alcohol. There. And the next one we're looking at is ethanal, which is an aldehyde. And the last 2 are not specific chemicals, but rather they're groups of chemicals. So we have a methyl ketone and a methyl secondary alcohol. So a methyl ketone, something, for example, propanone, but it doesn't have to be propanone, it could be any ketone with a methyl group on the end of it. So I'm going to just draw the general formula for this one. So I've got R, which remember stands for pretty much any carbon group. I've got carbon, double bond oxygen, and the methyl group on the end. That's CH3 group. And here again, methyl secondary alcohol, for example, propanol, but it doesn't have to be propanol. Again, it could be any alcohol, any secondary alcohol with a methyl group on the end of it. And that's what the iodoform tests for. It tests for these methyl groups, because that's the thing that all 4 of these have in common. They all have a methyl group, there it is, adjacent to either a carbon double bond oxygen in an aldehyde or a ketone, or a carbon with an OH group on it. So you can see here that this ethanol has this methyl group adjacent to that C double bond O, and here ethanol has that methyl group adjacent to the C with the OH. This is the only primary alcohol which can do this, and this is the only aldehyde that can do this. So if you get, for example, a positive 2,4-DMPH test and a positive iodoform test, you've got one of these 2. If you've got a negative 2,4-DMPH test but a positive iodoform test, you've got one of these 2. If you've got a positive 2,4-DMPH, positive silver mirror, and a positive iodoform test, well, you've got to have ethanol. So it's a way of identifying things that have this methyl group adjacent to this carbon. Okay, so the equation, very straightforward. Yes, you do need to know this equation. Notice that I've made a carboxylic acid salt. Okay, so you can usually get away with just the carboxylic acid, so don't worry about it too much if you haven't got that one. But the major thing to look out for is 2 things. One, you have this, CHI3. That is a yellow precipitate. That tells me that this reaction has worked. You get the carboxylic acid, so it's a way of turning, for example, a ketone straight into a carboxylic acid. But I've lost the CH3 group on the end of my molecule. Okay, so that was here. The CH3 group has been lost, it's been replaced here. Now that means I've got 1 less carbon. So this is also a way of reducing the number of carbons in a chain. So I'll show you what you mean by the reaction underneath. I'm going to use ethanol as my example. So I'm going to start here with my ethanol molecule. It balances in exactly the same way. So I've got some iodine and some hydroxide. I'm going to make my product, my organic product. So you can see here, this is my carboxylic acid salts, but it's meth okay, rather than eth. This one has 2 carbons, this one only has 1 carbon. So it's a way of us reducing the number of carbons in my chain. And then I've got 3 sodium iodides and 3 waters. And very importantly, that CHI3, triiodomethane, which is my pale yellow precipitate. And that's what I'm looking out for in the test, because if I formed that, then this reaction has happened. All the other things are soluble. The iodine is sort of brown coloured, and that colour quickly fades, and you should get this pale yellow precipitate. But this doesn't just work with aldehydes and it doesn't just work with methanol and methyl ketones. It also works with these secondary alcohols. So I'm going to do the reaction for a methyl secondary alcohol. So again, I've got my R, I've got my C, OH, H, and I've got my CH3 group on the end. Okay, and I'm going to add some iodine. The only difference between this one and the one above is it balances slightly differently, but other than that, the reaction is pretty much the same. Notice again, I've lost that group on the end, making my carboxylic acid salts. So I've got 1 less carbon. I've now got the same products. I've got some sodium iodide, some water, H2O, and I've got my CHI3, my triiodomethane. Okay? What I'd like you to do now is to pause the video and have a go at doing the same, writing out the reaction, but for ethanol. Okay, so hopefully you've had a chance to pause the video and write out the reaction for ethanol. So I'm just going to go through that one quickly. So here I've got my carbon functional group with the methyl group on the end. Remember, we're testing for whether there is a methyl group on the end. It still balances in exactly the same way. I don't need an R then, because I've got my CH3 group, but I've got C and H, double bond O, O negative. Okay, I could put the Na positive in there if I want to. Okay, it makes it balance a little easier. So again, 5, 5, 1. And I've made triiodomethane. There's a short video where you can see this reaction. But as I said before, there are many examples of this on the internet, so I'm sure you can find some YouTube clips for the iodoform reaction. Okay, so that's the end of the iodoform page. It's just a very quick page looking at specifically at the iodoform reaction. So the last section of this notes is Grignards, and we're going to be coming up to that shortly. Okay, so see you soon.